This is Advanced Math 2.5 notes. That's Unit 2, Lesson 5. Okay, the title is Solving Radical Equations. And these are steps. You've done these before, but we're just writing the steps down again. Number 1, isolate the radical. That means get it by itself. Number 2, undo the radical by squaring both sides or cubing both sides, depending on the problem. 3, solve. 4, check. Now, part 4, a lot of kids think and feel, I don't need to check it. I know I'm right. I know I made no mistakes. I'm good. But this check is not just to see if you did your work right. It's also because extraneous solutions happen. You will make no mistakes. You'll do all your work correctly, and it doesn't work. The check work is important. All right, solve. Number 1, square root of 4x squared plus 9 equals 5. Step 1, isolate the radical. It's already by itself. Step 2, undo the radical. So we're going to square both sides. What I did to one side, I must do to the other. 4x squared plus 9 equals 25. Step 3, solve. Subtract the 9. 4x squared equals 16. Divide the 4. X squared equals 4. And solve. So square root both sides. Don't forget, when you square root both sides, you put plus or minus. That's when you square root both sides to solve. X equals plus or minus 2. And before I boxed it in, I should have checked it, so I'll check it now. Now your check work, how you check it, if you can just do it mentally, that's okay. If you write it down to check, that's fine. I'm not going to be searching for your check work so much as when an extraneous solution happens and you have that answer when you shouldn't, you will get docked points. Okay, I'm going to check positive 2. 2 squared is 4. 4 times 4 is 16. 16 plus 9 is 25. And the square root of 25 is 5. It works. I will show you the work for the negative. Again, how you do your check work is up to you. Okay, for negative 2 squared plus 9, we're going to check to see if that equals 5. All right, that was negative 2 times negative 2 is 4, positive 4. Positive 4 times 4 is 16 plus 9. The 16 plus 9 is 25. And the square root of 25 is still 5. So it works. So positive 2, negative 2 is a good answer. Okay. That's not always the case. Sometimes one answer may not work, in which case you cross that one out and only write down the one that does. Number 2. Square root of 3x plus 7 equals 2x. Step 1, isolate. It's already isolated. This radical here is already by itself. There's nothing outside that needs to be added, subtracted, multiplied, or divided. Or divided over to the other side. Step 2, undo the radical. Square both sides because it's a square root. We don't see the square there, but it is. And when you square both sides, you're squaring all of 2x, not just the x. Please keep that in mind. The reason we do this is because they are inverse functions. Square root and square root are inverses of each other, inverse operations. They undo each other. 2x times 2x is 4x squared. And we are ready to solve. Get everything over. 0 equals 4x squared minus 3x minus 7. 0 equals double bubble. I'm going to use 4x and 1x. You can try 2 and 2 first. Minus 7 plus 1, because I need it to multiply to negative 7. Negative 7, positive 4 adds up to the negative 3. Solve. X equals 7/4 and negative 1. Okay. Right here, set equal to 0, add the 7, divide the 4, and here just subtract the 1. I do want to do my check work. Checking the fractions not as easy to do in your head as the last one that when we plugged in the positive 2 on the previous problem. So let's see. When you plug it in, really quick side note, when you plug back in, always plug it into the original as it was printed on your paper. Before you moved anything around, before you squared both sides, the original printed problem. All right, so we are plugging in for x. We're going to try the 7/4. 7/4. Okay. 3 times 7 is 21 over 4. That does not reduce. Plus, I do want a common denominator. So I multiply top and bottom by 4. That's 28 over 4. Equals, that's 14 over 4. We can reduce that. 21 plus 28 is 49 over 4. Equals, divide top and bottom by 2. That's 7/2. And does that work? The square root of 49 over 4 is 7 over 2, which equals 7 over 2. Check. We're good. Okay, we're going to check the next one. I'm going to squeeze it in over here. This time I'm trying the -1. Square root of 3 times blank plus 7 equals 2 times blank. Again, always into the original problem. -1, -1. 3 times -1 is -3 plus 7. -3 plus 7 is 4. Square root of 4 is 2. Equals 2 times -1 is -2, and those do not equal each other, which means we have an extraneous solution. This one right here is not going to work. Our only solution is 7/4. So how am I going to know if you're checking or not, especially on a test where the big points are, is how you give me your answers. If this question was on the test and you give me both of those answers, I'm going to know you did not check. That one's extraneous. 7/4 is your only solution. Got it? All right. Number 3. 3 times the 4th root of x plus 3 equals 9. All right, step 1, isolate the radical. This number's in the front and I don't want it there. I don't subtract it to the other side. I divide it to the other side. And that gives me the 4th root of x plus 3 equals 9 divided by 3 is 3. That's step 1, isolate. Step 2, undo the radical. Instead of squaring both sides, I'm going to raise both sides to the 4th power. And that gives, those undo each other because they're inverse operations. X plus 3 equals 3 to the 4th is 81. Subtract your 3, x equals 78. This is one we can quickly check without having to do this extra work. 78 plus 3 is 81. The 4th root of 81, not the square root, the 4th root of 81 is 3, and 3 times 3 is 9. It works. We're good. This is your answer. If you don't like checking in your head, write it on paper and check if it works. Okay, number 4. Square root of x plus 5 plus the square root of x equals 5. Okay, this one's a little tricky because it has 2 square roots. Do not square both sides right now. Kids will do this. Square, 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 and all is good. That's not the way squaring both sides works. When you square both sides, you square the whole thing. So, what do I isolate if there's 2 radicals? Pick one to isolate. It does not matter. I'm going to pick the larger one, which means I'm moving the radical to the other side, the smaller radical. So root x plus 5 equals 5 minus the square root of x. Step 2, isolate, and that's where I square both sides. Now, this is the tricky part, squaring. When I square this side, I do not square it individually. You have to write it as quantity squared. Have to. If you square individually, little pieces, it's wrong. I'm not going to give you credit for that. They undo each other, so I'm left with x plus 5 equals 5 minus root x times 5 minus root x. x plus 5 equals 5 times 5 is 25. 5 times negative root x is minus 5 root x. Right there on the inside, I also get minus 5 root x. And at the end, a negative times a negative is a positive. Root x times root x is x. All right, I'm going to clean that up. X plus 5 equals 25 minus 10 root x plus x. Now, when you see this, you've done all the steps correctly, but you still have a radical. When you come to problems like this and you still have radicals, know that it's you're going to have to start back with step 1. You're going to go through and isolate, undo, solve, and check. So we have to go now and isolate. I'm going to subtract the 25. I'm also going to subtract the x. Oh, forgot to put it on this side. So the x is crossed out on both sides. 5 minus 25 is negative 20 equals negative 10 root x. Okay, so what am I doing? I'm going back to step 1 and isolating. Because the nature of this problem has that double radical, when I squared both sides, it got rid of the one on the left, but not the one on the right completely. Got rid of part of it, but not all of it. So I isolate. I still have to divide by negative 10. That is positive 2 equals square root of x. Undo the radical by squaring both sides. And x equals 4. I'm going to have you guys check that one on your own. So check it, see if it works. I'll check with you guys on class if 4 was a solution, an actual solution, or if it was an extraneous solution. Okay, I'm moving on to one of the harder ones that you will see on the test that are like this type of problem. Number 5. Square root of 2x minus 3 minus the square root of x plus 2 equals 1. All right, this is similar to the last one in that there's 2 radicals, but they're the same size. It's not like the last one was itty bitty, a little bit smaller. When they are the same size, pick one. It does not matter which one you move. I'm going to choose to move this one because it's easier to just add it to the other side. Gone here, left with just the single radical of 2x minus 3 equals, these are not like terms, so I write it as 1 plus the square root of x plus 2. And then I undo. I've isolated already, so now I'm ready to undo by squaring both sides. When you square both sides, it will undo the radical on the left side completely because a square root and square root, they're inverse operations, they undo each other. Here, you cannot square individually because say, oh, one squared and that squared, all is good. It doesn't work that way. Okay, left side 2x minus 3. Right side we have to FOIL. It's absolutely necessary. If you mess that up on the test, you're going to mess up big because you're going to lose a lot of points all over the place. All right. So this side is nice and clean. This side we're ready to FOIL. 2x minus 3 and do our double distribution. 1 times 1 is 1. 1 times that long square root is square root of x plus 2. And then now let's distribute the square root of x plus 2 times 1 is plus the square root of x plus 2. And the square root of x plus 2 times the square root of x plus 2. They undo the radicals because they're exactly the same base. So plus x plus 2. All right. I have like terms on this side. Let's see, I have a 1 and a 2. That gives me a 3. These guys right here are going to combine to 2 square root x plus 2. The radicals don't undo each other here because I'm adding, not multiplying. Plus x equals 2x minus 3. Okay, What do we want to move over? I'm going to subtract the 3, and minus the x. Gone here, gone here. 2x minus x is x. Negative 3 minus 3 is negative 6, not 0, be careful, equals 2 square root of x plus 2. All right, now it's tempting, and I really do want to divide both sides by 2. And technically you can, it's not wrong. Personally, I don't like to divide by 2 or 3 or 4, whatever's here, unless it's going to go into both the numbers evenly. Don't write this part, but if I were to do it, 6 divides by 2, but not the x, and I don't want fractions there, so I'm going to leave the 2 where it's at. Now I can only leave it there if it was multiplication. If it was 2 plus, I would have to subtract it to the other side. But since it's multiplication, I'm going to go straight to squaring both sides. Now you can see already why this is going to be more of a complicated problem. I squared both sides here, simplified, still have a radical, so I have to simplify more, isolate the radical, square both sides, and here I do have to do another double distribution. Yes, you'd be expected to do something like this on the test. Oh, when I square, I'm doing 2 times this radical times 2 times the radical, so it's 4 times x plus 2. Or think of it as distributing because it's multiplication. 2 squared is 4, radical x plus 2 squared is x plus 2, and we double distribute. X squared minus 12x plus 36 equals 4x plus 8. Whew. And now we're finally ready to solve. I'm going to subtract the 8 here, subtract the 4x here, and that gives me x squared minus 16x. 36 take away 8 is plus 28 equals 0. We get equal to 0, so we can factor and solve. And that is minus 14 minus 2. Multiplies, adds up. X equals 14 and 2. Same thing with this one. I'm going to have you check it. Now when you check it, both of these one at a time, goes way back up here to the original problem. Plug in your 14 times 2 minus 3, 14 plus 2, see if it works. Plug in the 2, 2 times 2 minus 3, 2 plus 2, work it all out. Maybe they both work, maybe only one works, maybe neither works. You do have to check, and I'll check in with you guys in class. That is it for this lesson.